Okay, let's take a look at some special circulatory routes. Up to this point, we've pretty much talked about circulatory routes that follow the simplest pathway, which means that from the heart, the blood travels through arteries, which then go to arterioles, capillary beds, venules, veins, and back to the heart. But there are other types of circulatory routes. The one that we're going to talk about is called a portal system, where blood travels through arteries from the heart, goes into a capillary bed, goes into a vein, so far normal, but now instead of going back to the heart, it goes through a second capillary bed before it goes into the veins and returns to the heart and to the full circulation. There are several of these special circulatory routes, these portal systems. One of them you learned about, I hope, in A&P1, even though it wasn't identified that way. But if you talked about the hypothalamus and the pituitary, you may remember that the hypothalamus secreted releasing hormones, which went to the pituitary, and then the pituitary made the actual hormone that did the work. Now, the hypothalamus did not really, if this is the capillary bed for the hypothalamus, it did not release the hormone into the main circulation, which went back to the heart, and then came out and went to the lungs, and then back to the heart, and then came around and went to every organ in the body, including the pituitary. That would be incredibly inefficient. Instead, it uses a portal system. So if this capillary bed represents the hypothalamus and this one represents the pituitary, what happens in this situation is that the hypothalamus produces its releasing hormones. Those travel to the pituitary where they leave the capillary bed, stimulate the pituitary, and then the pituitary secretes its hormones into that capillary bed, and then it goes into circulation where those hormones are going to be effective. Now, there are a few other circulatory routes I'm not going to talk about here. These are called anastomoses or alternate routes, but I'll just mention them because the diagram is there. These are shunts to bypass exchange completely, or just alternate routes to get to capillary beds that serve the tissues. Okay, let's go back to the portal system. We're going to look at what's called the hepatic portal system next. Hepatic means liver. So this one is completely focused on the liver and its important function in sorting through the materials that we bring into our body. So let's start with naming the vessels. We have the aorta and the vena cava, the inferior vena cava in this case. Coming off the aorta, we have arteries that travel to various organs. So here we have the gastric artery that's going to go to the stomach. It goes into capillary beds in the stomach, and in those capillary beds absorb substances that the stomach is capable of bringing into the bloodstream. This primarily includes things like aspirin, alcohol, not much that's actually nutritive or useful in that sense. But nonetheless, the materials come from inside the stomach, make it into this capillary bed, and then we'll talk about what happens next. There's also a mesenteric artery. Mesenteric artery travels to the small intestine, and in the small intestine, it picks up the nutrients that the small intestine is digesting and absorbing. We also have a hepatic artery, which brings oxygen-rich blood to the liver. And so there it is doing exchange. All right, so far, all of this looks like just a regular, simple circuit. just 3 of them for 3 different organs. And by the way, there's one other here that I couldn't fit in the slide. That's the splenic artery for the spleen. Okay, now once we've picked up these nutrients, or not nutrients in the case of alcohol, the blood goes through into the gastric vein. Now, normally we would expect the gastric vein to end up with the vena cava and just bring the blood back to the heart, but it doesn't. Nor does the blood from the mesenteric vein. It doesn't go to the vena cava because we don't want all of these substances to be circulating through the body until we've had a chance to check them out. So, the gastric vein, the mesenteric vein, and the splenic vein, which I don't have on here, all converge and send their blood into a vessel known as the hepatic portal vein. The hepatic portal vein also goes to the liver, and the blood in the hepatic portal vein mixes with the hepatic artery, passes through the capillaries, and the liver gets its oxygen from the blood that's arriving through the hepatic artery. But it also is looking at the blood arriving through the hepatic portal vein, and it takes those substances and it says, oh, this is toxic, and it detoxifies it and finds a way to eliminate it from the body, either by sending it to the small intestine or by putting it into a form that's non-toxic so that it can be put back in the blood and eliminated by the kidneys. If it's not a toxic substance, if it's something useful like an amino acid or some glucose that the body could use later, the liver holds on to it and stores it. If it's a useful substance that the body can use now, then the liver will put it back into the bloodstream and allow it to circulate to reach the tissues that need it. So the liver is the great sorting and storing organ. Okay. Once all of that blood has been sorted through and the toxins have been removed and the nutrients have been stored, or they're good to go to the rest of the body, the blood enters the hepatic vein, which connects with the inferior vena cava and goes back to the heart so that it can be sent to the general circulation. Now, I want to say one word about the spleen and the splenic circulation, especially because it's not pictured here, but also because it's something that we discussed a great deal in the chapter on blood. Remember that red blood cells, as they pass through the spleen, around the time that they're reaching 120 days, will rupture. And as they rupture, they release the hemoglobin, which has that toxic heme, that pigment inside it. So if we pretend for a moment that the stomach actually represents the spleen and that this is where the red blood cells are dying, then all of that is happening in these capillaries. We don't want that heme to go into the general circulation. It's toxic. So while the macrophages are busy chewing things up, all of that is traveling through the splenic vein to the hepatic portal vein to the liver, where the liver can do the sorting and convert the heme to bilirubin and all of those steps that we talked about in terms of the erythrocyte life cycle.